Okay. So I'm going to go through graphing one of each of these. Sine and cosine are both a wave. So I'm just going to do sine. Cosine looks really similar, but I'm just going to plot a few points. So if we want to plug in 0 pi, and let me just draw the unit circle real small over here. So 0 pi is right here. Sine is the y value. So the y value for that point is 0. So sine is going to start at 0, 0. And then we're just going to travel around the unit circle. For pi over 2, the y value is 1. So we get the point pi over 2, 1. Next coordinate point for pi, the y value is 0. So we will get pi 0. At 3 pi over 2, the y value is -1. So we'll be down here and then back to 0. And so it is going to do something like this. And then it's going to keep on going. I mean, you can continue that pattern forever and ever and ever. The only difference for cosine is going to start here and then do its wave. You guys learned that virtually last year, but is that looking familiar? Sort of?
Yep.
Good?
Yeah.
Okay. So secant and cosecant both have the same kind of shape. I'm just going to graph secant. Again, cosecant would look similar. Secant means that we have to flip the x value. So we're going to go around the unit circle, and whatever the x value is, we're going to reciprocate. So starting at 0 pi, the x value is 1. If you reciprocate that, you're going to get 1. 1 over 1 is 1. So we're going to start there. At pi over 2, the x value is 0. You can't flip 0. You get an undefined. So in the graph, that means that there will be an asymptote. At pi, we have our x value being -1. If you reciprocate that, it's going to be -1. Again, 1 over 1 is 1. And then down here at 3 pi over 2, our x value is 0. So when you reciprocate that, that gives you an undefined, and you get another asymptote. And then this pattern is going to continue each direction. You can keep on going. And you get these things that look like, oh, whoops, I went a little farther. I guess the next one would be down here. So you get these things that look like parabolas. They aren't parabolas, but for the sake of calling them something, I call them smiley faces and frowny faces, but it looks something like that. And cosecant would be the same. It would just start with an asymptote, and all of the little U shapes would be moved over a little bit. Since secant is the reciprocal of cosine, if you were to graph cosine, cosine would fit in here like this. And so what you've basically done is turned the cosine graph inside out. So do you remember all these U-shaped ones?
Yes.
Secant and cosecant. Okay, let me erase this part because that looks a little strange there. All right, and then lastly, for tangent and cotangent, you need to kind of do a rest stop. It's only going to go halfway around the unit circle. These points halfway are the square root of 2 over 2 points. So the pi over 4 and the 3 pi over 4. So if we start at 0, tangent is y over x. So 0 over 1 would just be 0. 0 divided by anything is going to just give you 0. Pi over 4, if we stop right here, you have root 2 over 2 over root 2 over 2. Anything over itself is going to be 1. So we get pi over 4, 1. At pi over 2, the y over the x, 1 over 0 is going to be undefined, so we get an asymptote. At 3 pi over 4, again, they're both the root 2 over 2. Those are going to cancel out and give you 1, but since we're in the second quadrant, it is going to be -1. So we're going to have a point down here. And then at pi, again, tangent would be the y value over the x value. 0 over -1 is going to be 0. And then the pattern is going to just continue. So we get -1, 0, 1, and then an asymptote. And then that's going to continue. -1, 0, 1, asymptote. And you get these wiggly shapes. Cotangent will look similar, but cotangent will be decreasing. So those graphs will be going downwards.